Shalom to you and welcome. In our previous lessons, we looked at 4 ways to form a form angle on a circle. So one is when the vertex is at the center. In that case, the angle is equal to the arc that it intercepts. The second one is when it is inscribed when the vertex is on the circle. In that case, the angle is 1/2 of the arc it intercepts. Or if it is with tangent, the same thing. Okay, again, you have to look at the arc that is in between the two sides of the angle. So this angle, arc AB, is twice the measure of angle ABC. So angle ABC or angle B is 1/2 of the arc AB. So the third one is when the vertex is inside the circle but not at the center. So not at the center like this. So this is the vertex. It's formed by 2 chords. But in this case, we see we have 2 arcs, intercepting arc, because this is x and x is equal to the opposite angle here because they are vertical angle. So you're thinking about arc AB and arc DC, they are going to be equal as well. So because you have two arcs, you're going to add them. So again, and then you're going to find 1/2 of that arc AB plus arc AC. And that's the theorem we are going to look at. The fourth one is when the vertex is outside the circle like this. The vertex is outside, still formed by a secant and tangent, or 2 secants, or even 2 tangents. We can actually, like this one, okay, like this one, we have the theorem. So it can either form by 2 secants, 2 tangents, or 1 secant and 1 tangent mixed together. So the theorem says the measure of the angle formed by 2 secants, 2 tangents, or a secant and a tangent drawn from a point outside the circle is equal to 1/2 the difference of the measures. So if the vertex is outside the circle, then we subtract the difference, we subtract the measure of the arcs. But if the angle is inside, like this one, if the angle is inside the circle, we add the arcs. And so the theorem says the measure of an angle formed by 2 chords that intersect inside the circle is equal to half the sum. Inside, sum. Outside the circle, difference. Okay, so let's solve some problems with that. So here, given this figure, okay, so we see this is the center of the circle. This is where the vertex is formed for angle 85. We're asked to find the measure of arc RS. Arc RS is right here. So if we notice, first of all, if this was central angle, we will say that RS is the same as this, but because this is not the center, it's not at this point, it's going to be different. We're going to consider both arc TU and arc RS. And so this vertex here, it's going to be the 85, which is the angle 85, is going to equal 1/2 the sum of arc TU, the sum of arc TU, which is 105, plus arc RS. Let's label that RS X, so that way we have only one variable to deal with. So plus X. Okay, so that's the statement. The angle is equal to 1/2 the sum of the 2 arcs. So now we do the algebra. So we can multiply both sides by 2. If we multiply both sides by 2, so 85 times 2 is 170. So this is 170 is equal to 105 plus x. So that multiplication got rid of this. So now we're going to subtract 105 from both sides. So 170 minus 105, 65. So 65 is equal to x. So that means the measure of RS is then 65. Okay. Again, when it's inside the circle, not at the center, we add the arcs and find it by 1/2 of it, or dividing by 2 gives us the angle. Whether it's this side or this side, they are the same. Okay, second one. Okay, let's look at this one. We find the measure of angle S. Angle S is over here. Okay, this is outside the circle. It's outside. Okay, formed by 2 tangents. So again, we consider the 2 arcs that intercept this arc and the remaining whole arc, all this arc. Okay, so and we don't know this arc, but we can find it because this arc and arc RT is equal to 360. So let's find that first. So we do, okay, 360 minus 110 is equal to, oh, sorry about this. Okay, 360 minus 110, you have 250. So we have 250. So this arc is 250, and because this angle is outside, we are going to subtract the arcs. So bigger arc minus smaller arc. Okay. So then angle S is going to be 1/2 of the bigger arc, which you just found, 250, minus the smaller arc, which is 110. So we can do 250 minus 110 is 140. So we have angle S is equal to 1/2 of means multiplication of 140, because that's what this gets. So 1/2 of 140, angle S, 1/2 of 140 is then, it's 70. So that the measure of angle S should be 70. Okay. Next, here we are asked to find the measure of arc UV. Okay, UV is right here, this tiny part. All right, UV is here. Again, the angle is outside, so we are going to subtract. So angle S is going to equal 1/2 of the 2 arcs, which is this arc that is in between the 2 sides of the angle and this arc. So we subtract the bigger arc, which is 55, minus the smaller arc, which is UV. Let's call it X. Minus X. And we actually have angle S. Angle S is 20. It's given to us. So we replace this with 20. And we cannot simplify 55 minus X because they are not like terms. So we leave it like that. So but we can multiply both sides by 2. Multiply both sides by 2 over 1. So multiply this by 2, so that gives us 40. That will get rid of 1/2, and then we have 55 minus X, and we can actually add X to both sides to make it positive. So that would be X plus 40 equals 55. and then now we can subtract 40 from both sides, and that would give us 55 minus 40. Okay, so we have 55 minus 40, just to check to make sure it's 15. So x then is going to equal 15. Therefore the measure of this arc is 15.